Okay, so the golden rule with solving equations is when we solve an equation, we need to use something called an inverse operation, an inverse operation. Who can tell me what inverse operations are? Who thinks that they can tell me an idea? You can put your answers in the chat for me. What do we think an inverse operation is? Try and think about what those words mean. And if you want, you can give me an example. If I gave you a plus sign, what do you think the inverse of that would be? Exactly. The other way around is a great way of thinking of it. That's a great way of thinking. Beautiful. The opposite, beautiful, another great way. Exactly. So if I asked you for the inverse operation of a plus sign, what would that be? What would be the inverse operation of a plus sign? Minus. Excellent. Okay, so the inverse operation of a plus sign would be a minus. And if I had a multiplication sign, what would be our inverse operation of a multiplication sign? Beautiful. Division. Okay. So when we're doing an equation, we do the opposite of what we're seeing. If we are adding a number, we are going to subtract it. If we are multiplying a number, we are going to divide it. So we always do the opposite of what that operation is. Okay, and then what do you do to one side of the equation? You have to do to the other side of the equation. You need to think of equations like those old school scales. I don't know if any of you have them in science class still. There's like a scale, and then you have to sort of weigh things up. So as long as whatever you are putting on this side is the same as what you're putting on this side, then the scale stays even. And that's what we're wanting to do in equations. So whatever we do to one side, we have to do it to the other side to keep that scale in line with each other. Okay, and if you're worried and you're a little bit confused, please don't panic. I promise we are going to go through this nice and slowly, so everything will be okay. All right, what we're meaning here, so if we're looking at this little scale over here, if I'm minusing 5 on this side of the equation, and when we say sides, they're broken up by the equal sign. The equal sign breaks up the different sides of our equation. If we minus 5 on one side, we need to minus 5 on the other. So whatever we do to one, we have to do to the other. Okay. If anyone would like to take a screenshot of this first little explanation, now would be the time. And then we're going to move on to some examples. Okay. All right, before I move on, does anyone have a question about what they are currently seeing? If you do, you can raise your hand and let me know. It needs to be about what is on the board right now. If anyone is feeling confused about what they're seeing, let me know. Beautiful. Nice job, guys. Okay, let's keep going then. So sometimes when we work with equations, a nice sort of way to get started in them is by using flow diagrams. Flow diagrams, I think some of you would have done them in grade 7 in primary school. Some of you may have actually done them also this year. But flow diagrams are just a way for us to figure out what's going on. So in this, it's asking us to write the equation that is represented by this flow diagram. Who thinks they can tell me what this equation would look like? Do you think you can put your answers in the chat for me? There are 2 different ways of writing this equation. One way, which is like amazing. If someone does that, I'm going to be so excited. And then another way, which is also great, but we'll see. So you're absolutely right, Morgan. You would reverse operation if you were trying to find x. But for now, let's not try find x. How would I write this equation? How would I take this flow diagram and turn it into an equation? Okay. So what you're all doing is at the moment, you're sort of trying to figure out what x is. Absolutely, we use flow diagrams to find x. So you're all doing a great job at solving for x. But the first part of this question is asking us to write the equation. Who thinks they can help me write the equation? You're all doing a super job with solving for x. Ah, look at that. Beautiful to tender, 100%. We're going to use x just because we're not working with tn and n. We're working with x's, but what you've said is absolutely perfect. Okay, so the first thing that happens to x is we are timesing it by 6. So we're going to say 6x, because remember, when the number is right next to the variable, then that means times. Okay, remember that's what that means. So we don't need to write the times sign. We can just say 6x. Then the next thing that's happening is we are adding 5, and that's all equal to 29. Okay, so if we had to write this as an equation, that is what that would look like. That's what we're seeking. And you could also write this as 6 times x if you want to. That's absolutely fine. Then the part of this that you were all doing so well is solving for x. And when we're solving for x, we work backwards. So again, we're going to do the opposite. We're going to do the inverse operation. So we first plus 5. Now remember this idea that we said what you do to one side, you do to the other. When we minus 5, we're minusing 5 from both sides. And that 5 goes away because 5 minus 5 is nothing. And then on the right-hand side, 29 minus 5 is going to give us 24. Now, you don't have to write all your steps like this. I'm going to show you some quicker ways of writing your steps. I'm just going to show you here what's actually happening so you understand why you are doing the inverse of each thing. Okay, so now we land up with 6x is equal to 24, and you all told me just now what the opposite or the inverse operation of multiply is. What is the inverse of multiply? What do we need to do to both sides here to get x to be alone? We want x to be all alone. So what do we need to do both sides? Yes, good. We need to divide both sides. So we are going to divide this side by 6, and we are going to divide that side by 6. So 6 divided by 6 is 1. So now we get x to be all alone. We're going to use this sign over here, which means therefore. And then we have 24 divided by 6, which is going to give us 4. Oh, so Teacher Sam will be back on Wednesday. I'm just here for today. She's just got some parent meetings tonight. So you've just got Teacher Jen for this evening. Okay, so that's what we're meaning when we say you're going to do the same thing to both sides. Now, an easier way to think about this is that when we move to the other side of the equal sign, we do the opposite operation, okay? So I like to think of it as like a magic equal sign. So we've got 6x plus 5 is equal to 29, okay? Let's just think about this 5 first. When he jumps over the equal sign, it's going to become a minus. So we can write that as 6x is equal to 29 minus 5. So he's jumping over and he's going to become the opposite sign. Then we don't need to show it on both sides because we know what we're doing. Okay, so that means then that 6x is equal to 24. And then we do the exact same thing we did just now. We divide both sides by 6 and we get our answer 4x. Okay. All right, I'm going to quickly have a look at the chat here. Does anyone have any questions about example 1 before I move you on to example 2? If you have questions, please let me know, put them in the chat so that I can answer you. If for some reason you aren't able to see my screen, the best thing to do is to quickly leave the call and then come back in, and then it should be absolutely fine. Okay, Chloe, don't panic. We're going to go through example 2, and then I think things are going to start falling into place. And if they don't fall into place, that's also okay. Okay, so for those of you who are feeling a little bit lost, this flow diagram over here, it's helping us write out the equation. And then to work it out, we just work backwards. So here we would say 29 minus 5, and that would give us 24. And then we're going to do divided by 6 because we always do the inverse. So we would say 24 divided by 6, and then that would give us our answer 4. how did we get to 6? So 6 was just what this was. That was 6x. Okay, so that meant 6 times x. And so the reason we divided by 6 is because we're wanting to do the opposite. And so if we're timesing by 6, then on the other side, we want to divide by 6. Remember, when we write it as a fraction like that, it just means divide. Maybe the fraction is confusing you guys. Let me write it a slightly different way. So let's say we have the 6x over here is equal to 24. Then x would, oh goodness, that x has gone a little bit haywire. Let's fix it up a little bit. Then this x would equal 24 divided by 6, because we were timesing by 6 on the left-hand side. And that would then give us our answer of 4. I'm happy to write it out like that if that makes it feel better. So the variable x comes from the question. So they're asking us to solve for x. And so that's what we're seeking. So we're trying to find out what x is. Whenever you see this sentence over here, solve for x, it means we're trying to find x. Okay. All right, I will come back here, but if you would like to take a screenshot, you can. And then I'm going to move on to example 2, and I'm going to give you a little bit of time to try and figure out what's happening in example 2. And then we're going to talk about it together. Okay. And remember, if you have questions, just ask away. Okay, so here is question 2. So I want you to do a very similar thing. I want you to write the equation, and I want you to find out what x is. So I want you to solve for x, and I want you to write out the equation.
Let's go, my people. We can do this. We can absolutely do this. So the same example that Teacher Jan gave us, let's just continue and try to get this one right. Okay.
Yeah, you guys are doing really well, though.
Yep, they're understanding. I'm so proud of them.
When you think you have an answer, just pop it in the chat for me. So just put whatever you think your answer would be. I'm looking for the equation, and then we're also going to solve for x. We're going to solve for x a whole bunch of different ways in this question. Okay, so we're getting our first answers coming in. Remember, inverse operations, whatever you're doing, if it's a minus, we're going to plus. If it's divide, we're going to times. So just think about it like that. And then let's see if we have someone who's going to be brave enough to figure out this equation, because this equation is quite a hard one to write out. I'm going to be honest. Okay, we're getting a whole bunch of different answers. That's great. Keep on trying, keep on doing your best. I never mind if your answers are wrong, as long as you are trying. That is all that matters to me. Oh, so close. It's very close. I like some of it. Okay, I'm going to give you guys 1 more minute, and then I'm going to start going through this. Could be. Okay, I'm going to do this a slightly different way. I'm going to start by solving this, and I'm going to solve it by just using our flow diagram, because I think that's a little bit easier in the beginning. Okay, so remember, when we solve for x, we do the opposite of everything. So we take -7 and we plus 10. Okay, so we're saying -7 plus 10, and that's going to give us 3. Next step. If we were dividing by 2, what are we going to do in this next step? Think about the inverse operation. If we were dividing by 2, what would be next? Good. We're going to times by 2. So we're going to say 3 times 2, and that's going to give us 6. Next step, if we were plussing 4, what would we do now? Good. We're going to minus 4. So we're going to say 6 minus 4, and that gives us 2. And so our final answer here is 2. So if we had anyone who managed to solve x is equal to 2, oh, well done to you. You got it right. That's awesome. And that's just using our flow diagram. Now we're going to try and figure out how we can put this monster of an equation into an actual written equation and then to solve it as an equation. And hopefully we get to that same answer. Okay. So let's look at this step by step. What is the very first thing that is happening to x? What am I first doing to x? I saw some of you were saying multiplied by 4, but just be careful. What's happening in that first box? Am I timesing by 4? Good, let's hubble, perfect. Okay, so the very first thing that happened to x is that I added 4. I said x plus 4. Perfect. Okay, and then what did I do after that? I then divided by 2. So I took all of this and I divided it by 2. And then I subtracted 10, and that was equal to minus 7. So that is what that equation would look like. Another way of writing that equation is we could have written it as x plus 4 in brackets, but those brackets are super important because that has to happen first. Divided by 2 minus 10 is equal to negative 7. So I think a few of you got to this point over here. The only thing you didn't have were the brackets. But the brackets are super important because the brackets are making sure that that plus 4 happens first. Okay. So let's see now how we would solve this. We're going to do that same process we did just now. Whatever we do, we're going to do when it jumps over the equal sign, we're going to do the opposite. Okay, so we've got this minus 10 over here. When he jumps over, he's going to become plus 10. So we're going to have the x plus 4 over 2, and that's going to equal negative 7 plus 10 because he's jumping over. Okay, and so x plus 4 divided by 2 is going to equal 3, which is what we got in our first step when we did our flow diagram. Then the next thing we want to do is we've got this divided by 2 situation happening over here. So when he jumps up, instead of dividing by 2, we're going to times by 2. I'm running out of space because I'm writing like a maniac. So I'm going to just write over here. So we're going to have x plus 4 is equal to 3 times 2. And so we get x plus 4 is equal to 6. And that was what we got over there. And then the very last step is all we're going to do is take this 4 over, and it was plus, and now we are going to minus it. So we're going to say x is equal to 6 minus 4, which means x is equal to 2. Okay, I'd love to hear how this one went, if you did everything right, if you did everything wrong, if you didn't understand some things, but you understand them now, or anything. I'd love to hear anything about this question. Please pop it in the chat for me so I can hear how this question went. If there were things you messed up, but you understand why you messed them up, I'd love to know. Oh, good, Chloe. I'm so glad. Okay, Abongile, that's okay. Which part is still confusing you? Okay, so that minus 4 is because what we're doing is we're doing the opposite of what was ever in that block. Because when we're doing our equations, we do inverse of everything. So because it had a plus 4 there, the inverse of that would be a minus 4. We're always going to do the opposite of it. Oh, that's okay. So we got the 3 by saying negative 7 plus 10. That's what gave us that 3 over there. Okay, great. And then the 6 came by saying 3 times 2. 3 times 2 gave us the 6 over here. Awesome, guys. It's okay. If you're still feeling a little bit lost or a little bit stressed, please don't panic. We got lots of time left in this lesson. We're going to do lots of questions together. Some of them are going to be so super easy and some of them are going to be a bit trickier. So don't you panic. Okay. We're going to start with some nice, easy questions. If you want to take a screenshot of this, you're welcome to. This is as hard of a question as these can possibly get in grade 8. So I don't want you to panic. So the 3 came from this step over here. So we had -7 plus 10, and that's what gave us our answer of 3. And over here, we had the 3 times 2, and that gave us that answer of 6. So the brackets are there to make sure that this happens first. We need to make sure that we're adding the 4 first, because otherwise, because of BODMAS, that divide would happen first. Okay. I'm going to move to some nice, easy examples as we run through this. We're going to do a couple ones, and then we're going to take a nice brain break. This is going to be so nice and easy compared to that. You guys are going to feel like absolute geniuses. Okay. I am looking for the answer for X. Now, I know a lot of you can do this in your head, but I want you to, on your paper, on your side, I want you to try and show your steps, because remember in maths, you get works for your marks for working out. So make sure you show me exactly what you've done in this question. And then we can see what your answers are. All right. Nelson, can you talk me through how to do this question? Oh, Nelson, I can't hear you at all. Is your headphones, are they plugged in? I'm not sure what's happening there. I'm seeing great answers, guys. Nice. The topic is equations. Okay, so lots of you can see that that should be a 6. And so what I'm seeing a lot of people writing in the chat is 6 plus 2 is equal to 8. Okay, now you're not wrong. 6 plus 2 is absolutely equal to 8, but that's not how we show our working when we do equations. We've got to be quite careful, because remember, maths people are like very specific. They want things done a specific way, so we've got to kind of follow on with what they want. So over here, we had a plus 2. So when he's jumping over, it's going to become a minus 2. So we're going to have x is equal to 8 minus 2. And then we just work out what that is. So 8 minus 2 just gives us 6. So this is the working out that we need to see. Okay. Now, some of your teachers may have taught you a slightly different way. Some teachers like seeing the actual work done on both sides. So I'm just going to show you what that would look like if we had x plus 2 is equal to 8. Some teachers like to see that you are subtracting 2 from both sides like that. And then you would get your answer of x is equal to 6. If your teacher wants you to do it like that, please continue to do it like that. I don't want you to get into trouble in class. That's perfect like that. Okay, so just be careful to show your working. All right, let's move on to that next one. Also, just be careful not to do something called part sums. So we don't want to do something called part sums. They're not our friend. A part sum means we show pieces of it. So like we show that separately. So we basically have our equation written like this. And then we have a part sum. So we say 8 minus 2 is equal to 6. And then we say, therefore, x is equal to 6. We don't want to do that. Okay, that's called a part sum. We want to show the full process of what's happening to x from the beginning. Okay. Beautiful. I'm going to move on to our next one. Let's see how we go. Also, this is just like my teacher used to be so strict about it. So now it's sort of grilled into my head that this is what I do. Not all of your teachers will be as strict about it. My math teacher in school always wanted my equal signs to be under each other. It's just like makes your work look nice and neat. It does actually help as you move into the higher grades when things start getting more confusing. So if you get into that habit now, it will help you later on. But you do you. Yeah, also yours. Sometimes the math teachers can be great. I'm saying this as a math teacher. I know I'm also to blame. Okay, let's do another nice easy one. Oh. Yeah, lots of math teachers are wanting you to do that, hey? Okay, another super nice easy one. Now that we've spoken about the setting up and not doing part sums, I want to make sure you write this 100% correctly. So think about what you did in the last one. Think about the mistakes you made and don't make those mistakes in this question, because this is very, very similar. Good. 10 is absolutely the right answer. Just make sure you're showing you're working correctly. Joshua, I'm not sure why you can't see my face. My video is on. Nice job, guys. Okay, so we can see we've got this -2 over here. We're wanting to move it over. When it jumps over, it changes the opposite sign. So it was -2, and now it's going to become +2. And so our final answer is x is equal to 10. Yes, Brooklyn, that working. Magic. And Watobe, beautiful. Gorgeous, guys. I'm loving this working. Okay, so these ones should feel nice and easy. We're going to do 2 quick other ones, and then we're going to jump into our brain break, okay? Okay, so just be careful not to say minus, because remember when it jumps over, it changes sign. So over here it was minus, so we always do the opposite, so then it's going to become a plus. Whatever is happening on the one side, we're going to do the opposite when we're on the right side. Exactly, we want to have letters on the one side and we want to have numbers on the other side. We're going to talk about that when our questions get a little bit more complicated. Okay, cool. Let's do this one. We're going to do 2 more. So we're going to do 3 and 4, and then we're going to take a quick brain break. This one should also feel nice and easy. I want you to think about, what does it mean when we have a number right next to a letter like that? What does that mean when we have that 3x? When we've got that number right next to the letter, what does that mean? Good, it means times. That means 3 times x. Okay, so just be careful when you're working through that. And then think about what your answer is going to be. Nice job, guys. 21 divided by 3. Yes. Again, we want to show all of those steps of working. I'm going to show you different ways of writing this question. I'm a big fan of using the fraction divide sign. It just keeps things nice and neat and easy. So, for example, here, we've got 3x. So we're going to divide by 3, and we're going to divide by 3. And it always just makes sure we're dividing by the correct thing. And so therefore x is equal to 7. That's how I would work it out. That's just what my brain finds easier. But if you preferred, we had 3x is equal to 21. If you prefer writing it out the other way, we can say x, let's just get a different color, blue. Okay, so x is equal to 21 divided by 3, which means x is equal to 7. You can also absolutely write it out like that. That's fine. Just remember, don't write it out as a part sum. So don't write out 21 divided by 3 is equal to 7. Therefore, x is equal to 7. Nice job. Okay, one more, and then we're going to go into our brain break. Okay. Question 4. So this one, we're going to have to do 2 steps now. So we're going to have to deal, oh goodness, we're going to have to deal with this +4, and then we're going to have to deal with this times 2. And we need to show all of our steps of working as we work through this. Oh, I'm liking that answer, Lolita. Nice. I'm going to give you just a little bit of extra time for those of you who are still working it out, and then we're going to go through it. Just remember to not do it as part sums. Okay, so we're going to start with that +4 that we have over there. So we're going to have 2x is equal to 14, and it was a plus, so we're going to minus. So we're going to minus that 4 over there. So now we have 2x is equal to 10. And then we need to divide by that 2, and we need to divide by 2. So those two cancel, and we get x is equal to 5. Now at this step here, I'm just going to write it out using our divide sign in case you are struggling with the fraction. So 2x is equal to 10, which means x is equal to 10 divided by 2, which means x is equal to 5. Okay. Nice job, guys. You're doing great. If you want to take a screenshot, I'm going to zoom out so that you can see all 4 of them at the same time. And then you can take a screenshot if you would like one. Ooh, that's a bit too extreme of zooming. Here we go. And then I'm going to go down for a brain break. Okay. I'm trying to, we'll come back to this one. Don't panic, guys. Trying to make sure I don't ruin Teacher Sam's joke before this. Okay, so your brain break for today is how many squares are there in this picture? How many squares are there in this picture? There are more than 10 squares. There are more than 9. Yeah, I can zoom out of it. So I think we're just guessing some numbers here. 54. Where's the 54 coming from?
54, that's over exaggerated. 54, it's a lot.
So some of you have gotten it right though, which is good. Okay, so let's go through. So we've got our individual ones, each of those. So that's obviously the 9. So we've got 9 squares. And then we've got our big one. So that's +1. Okay. But then we also have these ones. So we've got like 1 there, 1 there, 1 there, and 1 there. So that gives us another 4, and so that gives us 14. I get 14, but if you're seeing there's more, those of you who are seeing 15, I'd love to know where the 15 is coming from. If you're seeing an extra one, just let me know. If I'm missing one, I could I mean, I could be. It's been a long day, guys. Okay. 243. You're crazy. Crazy. Square. You know what, Chloe, I will give that to you. The word square is also a square. I will give that to you because that is genius. You deserve 500 points for geniusness.
Oh my word. The word square is also counted as a square.
I love it. I love it. Well done, man. Okay. Okay, so Teacher Sam always has a joke for those of you who are new. Teacher Sam is very, very funny. And she has a joke for us today. I think she actually has 2 jokes for us today, if I remember correctly. Okay, let's have a look at the first one. Okay, first joke of the day. Surgeon says, "Nurse, I have so many patients. Who do I work on first?" And then the nurse says, "Simple, follow the order of operations."
Nice.
Yes, it's a good, you guys.
Nice one.
I don't have to take the blame if you guys find them corny. Oh, the yellow box. Okay, so Teboho, I would have given that to you if it was a square, but the yellow box is a rectangle.
And now everybody's confused at the joke.
Oh no, are we confused at the joke? The surgeon just doesn't know who to work on first, and so then the nurse is saying follow the order of the operations, but that's a maths term. Order of operations is like your plus, your minus, your times, divide. Too corny. Tatenda, I will pass it on to Teacher Sam. Yeah, it's just a maths joke. Okay. All right, I'm going to pop up so we can do another question. I think we can fit a couple more questions in before we have to leave. So let's try and do this one. Now, this one's a little bit of a juicier question because now we're dealing with a minus sign. I love me some negatives. Yes, Ndile understands the joke. I love it. Okay, so now this one is out there to catch you. I'm just going to warn you, it's spicy. The whole purpose of this question is to try and trick you. I want you to think very carefully about what's happening. I'm going to write a step under it, which I hope is going to make things a little bit clearer. But maybe it won't. So I want you to think super carefully about how to do this question. Don't fall for the trap. Was there a little hint? Okay, so I see some answers. Some people have fallen for the trap and some people haven't. So that is both good and bad. Let's go through this step by step, right? The first thing is we've got this +3 over here. So when it jumps over, it's going to become -3. So we're going to have -5x is equal to 23 minus 3. So we're going to have -5x is equal to 20. Who can tell me what I have to do now? So now I've got -5x is equal to 20. What do I have to do now? Good, good. Mavuyo, excellent. I have to divide by -5. I always divide by whatever that number is in front of x. And in this case, the number that's in front of x is a negative. And so that's what I'm going to divide by. You always divide by whatever that number is. So we divide by -5. And so we're going to divide by -5 on this side. And so now those two are going to cancel. So we're left with just x alone on this side. And then we have to think about our rules with signs. So we have a positive that is being divided by a negative. So we're going to get a negative answer. And then 20 divided by 5 is going to give us a 4. So we're going to land up with x is equal to -4. So the only trick about this question was they had that -5, because often what people do is they see that it's a -5 and they think, okay, when I move it over, it must be opposite. So I'm going to say +5. But you need to think carefully. We're timesing by -5, which means we need to divide by -5. So we're not plussing or minusing, we're timesing and then dividing. You got a wild answer. So I'm just going to write this out a slightly different way. So we've got -5 times x is equal to 20. Okay, and so if I need to do the opposite of times -5, it's going to be divide. So we're going to say x is equal to 20 divided by -5. A positive divided by a negative is a negative. 20 divided by 5 is 4. So that's just writing it out in a slightly different way. Okay. Take a screenshot if you'd like. We're going to do another question that's similar to this. So if you made mistakes in this question, in the next one, you'll be able to redeem yourself and hopefully get them right. Don't worry, guys. If you're having network issues, I really understand. ESCOM is very real. Okay. Let's give this one a try. So I want you to be super careful again. Think about what you're doing. As you're moving over the equal sign, think about each step. We're trying to figure out what our answer for x is going to be. Hello.
Hi, ma'am. I wanted
Are
to
you going
ask.
to give me an answer?
Yes, ma'am.
Brilliant. Tell me what you think I should do.
So I do it the way my teacher told me to do.
Good, good.
You move the 2 to the right hand side and plus it with 8.
Good. So we're going to have 3x is equal to -8 plus 2. Okay, so what is that 3x going to equal?
That 3x is ma'am. Okay, wait. With 3x. So 8 plus 2, it's gonna be -6.
Good. Excellent. Good, good, good. Okay, what am I going to do in this last step?
You divide both sides by 3.
Excellent.
And then on the other side, you put in x equals 3. No,
Okay, so just 2. Okay, and now be careful. If we have a negative and a positive, what is our answer going to be?
it's gonna be a negative.
Good. So it's going to be -2.
I get confused with the sign.
Yeah, the signs are tricky. Just remember, if the signs are the same, then it's always going to be positive. And if the signs are different, then it's always going to be negative.
Okay, thank you, ma'am.
Yeah, you're welcome. Have a lovely evening.